electric field at any point on the equatorial plane or line of dipole. So see here, as shown in the figure, consider the equatorial plane, and here the cross section of it is represented, right? So we take this equatorial line, and now we want to find the electric field at any point y, which one is situated at a distance r from the center of the dipole. So concept is simple. We have to take electric field at y due to positive charge as well as due to negative charge, and then after we can find the resultant one by taking the vector summation of these two fields. Clear? Okay. Now see here, from the center of the dipole, plus charge that is at a distance a, and negative charge that -1 that is also at distance a. Then center to y, that is r. So from each charge, this particular point that will be at a distance under root r square plus a square as per Pythagoras theorem. Clear? Now, E due to plus q charge. So magnitude wise we can write k q upon distance square, so under root r square plus a square whole square, so that is simply k q upon r square plus a square. And due to negative one, so E minus q, that is equal to k q upon r square plus a square. Same one. But see here, the direction of E plus q, that is outward here, means that is in the direction plus q to y direction. But due to negative charge, that is towards the charge, so that is from y to minus q. So E plus q and E minus q will be in the directions as shown in the figure. Now, if we consider here the angle theta as shown in the figure, then if we take the components of these electric fields in horizontal and vertical direction, then we will get for E plus q the component E plus q sine theta in positive y direction, means vertically upward, and in positive x direction we will get E plus q cos theta component. Similarly for E minus q, the components, so in positive x direction here we will get E minus q cos theta, and in negative y, means vertically downward, that will be E minus q sine theta. But see here, magnitude wise E plus q, this one, and E minus q, both are same one. It implies that E plus q sine theta and E minus q sine theta, which are equal in magnitude, opposite in direction, will cancel each other. It implies that here, see, when E plus q cos theta and E minus q cos theta both are in the same direction, then the resultant electric field, that will be the summation of this one. So we can write now net electric field at y, that is E plus q cos theta plus E minus q cos theta. But now see, the dipole moment, that is from negative charge to positive charge, so the direction of the dipole moment, that is this one. And now see here, at y, the net electric field, that is in the opposite direction of dipole moment. So we can write now net electric field E, that is E plus q cos theta plus E minus q cos theta. Now we have to multiply hereby minus P caret. Now, E plus Q cos theta and E minus Q cos theta are equal in magnitude. So we can write 2 times KQ upon R square plus A square cos theta. But from figure, we can write cos theta, that is adjacent upon hypotenuse. So A upon R square plus A square raised to 1 by 2. So here, see, we can write minus 2KQ upon R square plus A square cos theta is replaced by A upon R square plus A square whole raised to 1 by 2 into P caret. Now, resultantly, we can write therefore E equal to minus 2KQ into A upon this R square plus A square whole raised to 1 and this R square plus A square whole raised to 1 by 2. Resultantly will give you R square plus A square raised to 3 by 2 into P caret. So now this one is the equation of resultant electric field at point Y, which one is situated at distance R from the center of the dipole on the equatorial line. But this Q into 2A, that we can replace by dipole moment also. So in terms of dipole moment, our equation will be minus K P upon R square plus A square raised to 3 by 2 into P caret. Clear? So this one is the equation for electric field at any point situated at any distance on the equatorial line of the dipole. But again here we can consider one special case in which if we take R is very much greater than A, then again we can neglect A square. So we can write R square plus A square, that is nearly equal to R square. So here in this equation, if A square is neglected, then R square raised to 3 by 2 will give you R cube. So we can write E equal to minus KP upon R cube into P caret. So E proportional to 1 upon R cube. Okay. Now see here the equations. E that is equal to minus KP upon R cube into P caret. And here E that is K 2P upon R cube into P caret. It implies that if we consider 2 points, one on axis of the dipole, another one on the equatorial line of the dipole, at the same distance R, then from these equations we can say this thing: the electric field on the axis of the dipole, that will be twice than the electric field at any point on the equator of the dipole, for the points which are situated at the same distance. Clear to all of you?